Now let us try to solve the same circuit with the help of Norton's theorem. So in Norton's theorem, we would be requiring actually there would be two steps involved in converting this circuit into equivalent Norton form. So first step would be to find out IN, and the second would be to find out Zn. And please remember that finding out Zn is same as finding out Zth in case we found out in case of Thevenin's theorem. Okay, so to find out IN, we basically have to short circuit this. We'll be short circuiting this. So I short circuit this. So if I'm short circuiting this, that means this effectively this part, this goes. Okay, so the current, if IN is flowing here, the same current IN would be flowing here. So here, let me call the current flowing here as I1. Then I1, then I1 would be given by 6 angle 0 degrees divided by 1 plus J. Okay, so how I got this, basically this 6 angle 0 degree, which is a voltage source, is connected in parallel to the combination of these two impedances. So the current that would be flowing through them would be 6 angle 0 divided by the sum of these two impedances. So that's what I had written here. So this is equal to okay, fine. Now the current IN would be given by I1 plus 2 angle 0 degree, this current. So IN is this current plus this current. So this is equal to I1 is 6 angle 0 degree divided by 1 plus J, and this is equal to this plus 2 angle 0 degrees. So finally this would be 8 plus 2J divided by 1 plus J. Okay, and this is your IN. Now let's try to find out what would be Zn. So for Zn, the equivalent circuit is resistor, inductor, and this would be open circuited, this will be short circuited. Okay, so these are the 2 points across which we are interested in finding out the equivalent impedance. So this is J, this is minus J, this is 1, this is 1. So Zn equals 1 plus J times 1 minus J divided by 1 plus J into plus 1 minus J. So these two J's cancels, and finally we get this equal to 1. So this is 1 ohm. So the equivalent Norton circuit would be given by this current source, and we have got this impedance. This is this is Z N, and our resistance through which we are interested in finding out the current. So this is 1, and Zn was found to be 1, and this current IN we have found out to be equal to 8 plus 2J divided by 1 plus J. So finally I naught would be given by, if we apply the current rule here, so the current IN basically gets divided in these two branches. So I naught will be equal to in divided by 2. So if I reduce it, I would finally get this equal to 5 minus 3j divided by 2 amperes. Okay, so in all the cases we found that the current flowing through the resistance, 1 ohm resistance, it could be found out very easily, and now it's up to you to decide which method is better. Actually, it depends on a problem. So sometimes superposition theorem would be easier to apply for a particular problem, while in other cases Thevenin's or Norton would be easier to apply. So or in some other cases the nodal analysis would be much more easier. So you have to just make educated analysis to which of the methods should be applied to find out the parameter that has been asked in the question. Okay, thanks for now. I hope you enjoyed watching this video.